Hello, and welcome to another episode of Pre-Calculus with Miss Latham. In our last episode, we had just started discussing verifying trig identities. We wrote these down in class. The Pythagorean identities, which I know you all have memorized, the trig ratios, even and odd functions, and just as a reminder, our goal is to verify identities by making one side look like the other through a series of transformations using said formulas. We also wrote down some strategies that have been time tested and approved. One is starting with the side that looks the ugliest. Another is converting trig expressions simply to sine and cosine, finding a common denominator like you would when adding any fractions, separating a fraction that's a product, changing division to multiplication. Remember, dividing by a number is the same as multiplying by its reciprocal. Multiplying by a conjugate, factoring, and being okay with the idea that you might have to start over. My warnings were to be sure you don't move things from one side to the other, because we're trying to prove that these things are equal. We don't know it yet. And don't forget the variable when you're using your trig functions. So let's do some examples. Oh, I need more room. All right, number one. Oh, that paper's dirty. All right, for the first one, we've got cosine x, cosecant x, and cotangent x. All right, so we have this equation, and we want to prove that this is true. And to prove that this is true, we're going to manipulate one side to make it look like the other. So this one's pretty simple. It's just cotangent of x. So we probably need to start over here. So let's think about what we know. I know cotangent is cosine over sine. Over here, cosine is broken down as you can get, but cosecant, what is the same as cosecant? Cosecant's the reciprocal of what function? Sine. So I could change cosecant to 1 over the sine of x, right? And now, when I multiply these, that would give me the cosine of x over the sine of x, which, guess what, is the cotangent of x. And that's what we were trying to prove. See, now this side looks like that side. And I always put a check mark when I reach where I'm trying to, okay? It's like I met my goal. Check mark, makes you feel good. Let's do another one. The cotangent of negative x times the sine of x equals the negative cosine of x. So, which side looks the most complicated? This side, right? So we're probably going to be working with this side. So when I see this cotangent of negative x, I'm thinking we need to use our even and odd functions. Cotangent is an odd function. So this is the same as negative the cotangent of x times the sine of x. And you can write it like this, or if you feel better, putting a little dot in there. All right, well, we're trying to get to just cosine, so I need this sine to go away. So what we can do is we can change cotangent using its quotient, right? So I know that cotangent is just the cosine of x over the sine of x. And we still got to bring down that sine of x. This is what I'm talking about. It's important to make sure you keep your variable. Keep that x. Okay, and now what can we do? What's going to cancel out? The sine. So my problem is gone. We are left with the negative cosine of x. See? Ding, 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 ding. Check mark. All right, let's do another one. Ooh, pink. Sine of x times the secant of x equals the tangent of x. All right, so we know tangent is sine over cosine. And when I look over here, I've already got my sine. I need my cosine. What do we know about secant? What is secant the reciprocal of? Secant is the reciprocal of cosine. So I can change secant to 1 over the cosine of x. And now I'm going to multiply. Sine times 1 over cosine is the sine of x over the cosine of x. Some people might want to stick a 1 under that sine. Works for me. And what does sine over cosine equal? Tangent. Boom shakalaka. All right, let's do another one. And this time, after I write the problem down, I want you to pause the video and you try to work it out and then press play, okay? So for number 4, cotangent of x times the secant of x times the sine of x equals 1. Now hit pause and give it a try. All right, I'm assuming that you've worked this baby out. Let's get going. So cotangent is the same thing as the cosine of x over the sine of x. And secant is the same thing as 1 over the cosine of x. And I'm going to leave sine alone. Look, you got cosine in the numerator and the denominator. Cancel, cancel. I got sine in the denominator and sine in the numerator. Cancel, cancel. What are we left with? 1. That's what I wanted. Ka-ching. All right, let's try another one. I hope you notice how I've been writing every step out. Don't go skipping around. Make sure you put everything down. All right, let's try the cosecant of x minus the cosecant of x times the cosine squared of x equals the sine of x. We're getting a little spicy now. This is you got to think about this. So all I want is sine, and I got lots of stuff that's not sine. I noticed that both of these terms have cosecant. Oops, I left my C out. Oh dear. I noticed that now both of these terms have cosecant. So what I can do is factor by distributing. You remember back in the day in algebra how you could pull out a 2 or something like that? So I'm going to factor out a cosecant of x. And that'll leave me with cosecant divided by cosecant is 1. And cosecant times cosine squared divided by cosecant just leaves that cosine squared, right? All right, 1 minus cosine squared. I happen to know a formula that says that sine squared plus cosine squared equals 1. And if I move that cosine to the other side, I would have that sine squared equals 1 minus the cosine squared of x. So when we use the Pythagorean identities, it's not always going to be just straightforward. They may move things from one side of the equation to the other. 1 minus the cosine squared is sine squared. So for 1 minus the cosine squared, I'm going to fill in sine squared of x. We still have this. It's not going anywhere. I only want 1 sine. And right now I have 2 and cosecant. I need one of these to go away. What do we know about cosecant? Cosecant is the reciprocal of sine. Well, you have a sine in the denominator and 2 sines in the numerator. So this is going to cancel out one of your sines. And you're left with the sine of x, which is what you want. Okay? Let's continue with the spice. All right, this is going to be number 6. Let's do the secant of x minus the sine of x times the tangent of x equals cosine. or there's no question here about what side looks the most complicated. It's that side. Now this one's a little challenging, but if you want to, pause and give it a try. Okay, let's get started. So I got cosine over here and 0 cosines over here. So I got to do some work to bring some cosine into the game here, right? So I know secant is 1 over cosine. So that gives me some cosine, but it's in the wrong spot. And then we've got sine of x. And what about tangent of x? What's that equal to? Well, I know tangent is sine over cosine. All right, let's clean this up. This is a hot mess here. So we have 1 over cosine, and then sine times sine is just going to be sine squared. And that's on top of cosine. Well, since these bad mama jammas already have a common denominator, we should just probably put them together, right? So we have 1 minus the sine squared of x over the cosine of x. You see where this is going? You getting a tingly feeling in the back of your noggin? What's 1 minus sine squared going to equal? Think about your Pythagorean identities. I butchered that. Pythagorean identities. 1 minus sine squared is just cosine squared, right? And that's on top of cosine. What's going to happen? This cosine is going to knock out one of those cosines, and we're left with the cosine of x, which is where I was wanting to go. So, ka-ching. How are you feeling about all this? You're still there, right? Let's try another one that's not so bad. You can totally do this one. I have confidence in you. Number 7. For this one, we have cotangent squared of x plus cosine squared of x plus sine squared of x equals cosecant squared of x. Well, you have something straight off of Pythagorean identity right here. Do you see it? Look. Cosine squared plus sine squared. What is cosine squared plus sine squared? Well, that just equals 1. Wait a minute. You got yet another Pythagorean identity now, right? What's cotangent squared plus 1? Or 1 plus cotangent squared? That is cosecant squared. And boom, done. That one was easy. Let's do another one. All right, let's do cosine squared of x minus sine squared of x equals 1 minus 2 times the sine squared of x. Well, I got a negative sine squared, and over here I got 2 negative sine squareds, minus 2 times sine squared rather. And I've got that 1. So what needs to change over here? What do I need to leave alone, and what's got to go? I need this cosine squared to go away somewhere. It's not what I need. So let's think of a way we can replace cosine squared. And y'all, it's just back to those Pythagorean identities. If you've got sine squared plus cosine squared equals 1, if I want cosine squared by itself, I would move sine squared to the other side. So we have cosine squared is equal to 1 minus sine squared, right? So I'm going to take this cosine squared and I'm going to replace it with this. So now we have 1 minus sine squared of x for this cosine squared of x, and bring down this minus sine squared of x. Y'all, there's only one more step. These are like terms. I can put them together. Minus 1 sine squared minus another 1 sine squared is minus 2 sine squared. Ka-ching. Money. All right, let's do another one. Number 9. Sorry, I'm having problems with my marker too. All right, number 9. let's do the tangent of x plus the cotangent of x equals the secant of x times the cosecant of x. All right, remember that one helpful strategy where you turn things to sine and cosine? Let's do that right now. So I know tangent is just sine of x over the cosine of x. And I know cotangent is just the cosine of x over the sine of x. All right, I think we should add these two fractions. And to do that, I need a common denominator. I'm going to take it back old school right now and use the butterfly method. Yeah, that's right, the butterfly method. So, sine times sine is sine squared. Cosine times cosine is cosine squared. And then your bottom will be cosine times sine, and I'm just going to write cosine sine. I know I didn't do the little antennas. Ain't nobody got time for that. All right, sine squared plus cosine squared. What does that equal? That is 1. So we have 1 over the cosine of x times the sine of x. All right, and remember, one of our strategies is to break things up. So I'm going to break this up. I'm going to make it 1 over the cosine of x times 1 over the sine of x. Are you getting excited? We're almost there. 1 over cosine is secant. And 1 over sine is cosecant. Kachuga. Got it. What was that? You think you need more examples? No problem. I'll give you 2 more. Oops. Number 10. All right, let's do the cosine of x times the secant of x over the cotangent of x equals the tangent of x. I really think you ought to give this one a go. You should probably pause it and just try. All right, let's get going. So cosine is good, can't do anything with that. Secant, however, is 1 over cosine, right? And for now, I'm gonna leave cotangent alone. All right, what happens to those 2 cosines? Ka-chow, ka-chow. They're canceled. So I'm left with 1 over the cotangent of x. Don't you have a formula for this? 1 over cotangent's equal to what? Tangent. Done like toast, baby. Did you get it right? I told you could do this stuff. All right, last one. We got cosine squared of x times 1 plus tangent squared of x equals 1. All right, does any of this look familiar to you? It should. What does 1 plus tangent squared equal? 1 plus tangent squared equals secant squared. It's one of your Pythagorean identities. But what is secant equal to? Well, secant is equal to 1 over cosine. But since this is secant squared, it's going to be equal to 1 over cosine squared. I got a cosine up top and a cosine below. Cancel, cancel, and we're left with 1. I hope you have a wonderful rest of the day.